Good morning to one and all. My name is Manoj. I am studying first semester Information Technology. Topic is Square Lane. Subject Object Oriented Program. Introduction to Square Lane. Square Lane is a 2D computational geometry model where all entities are represented as squares with equal side lengths and fixed orientations. It serves as a foundational abstraction for collision detection, spatial partitioning, and grid-based simultaneous in OOPS environment. Each square is defined by its center coordinates xy and side length is s, forming a parametric geometric object. The model leverages encapsulations to store geometric properties and behave with a class structure. Square length simplifies real-world spatial, spatial problems by enforcing Lagrange boundaries for algorithmic efficiency. Class design and square entity. The square class encapsulates attributes, center object, side length double, and unique ID int for objective tracking. Constructor, constructors include default unit square, parameterized, custom center and side, and copy constructions for objective duplication. Private data members enforce data hiding, ensuring side length and center are modified only via controlled methods. The class implements the comparable interface and enables starting by a area A is equal to S side square in collections. Encapsulation and data handling. Encapsulation bundles data, side and center, and methods, area or perimeter, in a single class promoting modular design. Private access modifiers prevent direct manipulation of side length, enforcing validation through a sector methods. Cutting methods, example get area, provide read-only access, preserving object iterating during concurrent access. Validation in sectors ensures side length less than 0, throwing legal argument exception for a valid inputs. Inheritance specialized square types. The rectangle square class extends square adding width and height while maintaining square constraints for polymerization. A rotatable square subclass introduces a orientation angle theta, but restricts theta is equal to 0 or 90 degrees to preserve axis alignment. Inheritance allows shared a method, example area and calculation, to be reused, reducing code duplication across variances. The super keyword the super keyword initialize parent attributes, ensuring power object construction in the inheritance hierarchy. Polymerism in square operations. Polymerism method array dynamically resolves the subclasses specific implementations via method overriding. A square array can hold square, rectangle square, and rotatable square objects, enabling uniform processing. The instance of operator or visitor pattern handles type specific logs without breaking encapsulation. Dynamic dispatch ensures a correct perimeter calculation based on the objective type at runtime. This flexibility supports extensibility for future square variants without existing a code. Composition square grid system. A grid class composes a 2D array of square objects, modeling a titled environment for a spatial operations. Each cell I and j stores a square with a coordinate derived from a grid origin and spacing delta x and delta y. Composition ensures scaled lifetime controls square lifetime, preventing harpooned objects in memory. The grid class provides a method or neighbor lookup the Manhattan distance d is equal to I1 minus I2 plus J1 minus J2. This design enables efficient pathfinding and region-based consequences, in the scale simulations. Interfaces and drawable and movable. The drawable interfaces declares abstracts method, draw graphics and get bounds, prompting uniform reading. The movable interface defines move, dx, dy and get velocity methods for dynamic square behaviors. Squares implement these interfaces to support polymorphic and regarding and movement in simulate loops. Interface Interface second principle keeps context focused, avoiding bloated class hierarchies. Default method in interfaces Java 8 Plus provide backward compatibility, legacy and implementations. Collision detection algorithm. Axis aligned boundaries bounding box AABB collision check use coordinate comparison. X1 minus X2 is less than or equal to S1 plus S2 and Y1 minus Y2 is less than or greater than or equal to S1 plus S2. The separating axis theorem SAT confirms collisions if no axis exists where projections and squares do not overlap. For n squares, brute force collision detection runs in O(n) square time, necessitating spatial partition. Collision resolving involves computing penetration depth and applying inverse displacement vectors. Spatial partitioning coordinate tree. A coordinate tree partitions squares land into four quadratic resolving subdividing unit until node capacity is reached. Each node stores a bounding box min x, min y, min x and min xy and reference to child nodes and squares. Insertion uses recursive coordinate check the place squares and the appropriate leaf node. Event handling and square interactions. Mouse event click and drag and captured via mouse listener and mouse motion listener interfaces in GUI frameworks. The observer pattern allows squares to notify listeners, example scoreboard of the state changes without tight coupling. The squares class implements serializable and to enable object states prevented via Java object to output stream. Custom serialization write object or read object controls field serialization under and versioning serial version UID. Binary serialization reduces storage overhead critical for a large scale simultaneous and aeronautical data logging. Objective pooling reuses square instance minimizing garbage collection process in the real-time systems. Flyweight patterns share immutable properties across a multiple squares to reduce memory footprint. Weak references in caches allow garbage collection under memory pressure preventing leaks. Concurrency and square simulations. Thread-safe squares classes are methods and rehardened lock to prevent race conditions during updates. Concurrent has map stores grid cells allowing parallel read write access from multiple threads. Immutable squares variantations eliminate synchronizer needs enabling lock-free algorithms. Factory and singleton. Unit testing and JUnit integration. JUnit test to validate square methods such that area move using Ersted equals with tolerance for floating point errors. Mock object simulate depends such example graphics isolation using Mocktail frameworks. Continuous integration CI pipelines automate testing ensuring code in collaborative projects. Performing benchmarking. Integration with aeronautical systems. Square land models, runway grids, airspace settings, and sensors coverage areas in aviation applications. GPS coordinates are described into square cells enabling efficiency air traffic. Collision prediction. Real-time data fields upload square states via publish subscribe messaging systems. OOPS principle ensure modular integration with flight control control software and navigation databases. Shows the extensions and research. 3D square land extend to a model cubes enabling volumetric simulations for drone swaps and cargo packing. Thank you.